In this video, we will review cable preparation and how the CAU is utilized. We will install a mid-sheath cable and attach a lateral branch. This is installed in a 6-ground Apex X2 with an inner basket. The tools needed for installing Apex include a can wrench, optional 3/8 inch by 7/16 inch ratchet wrench, cable prep tools, splicing tools, safety glasses, and all other safety equipment required by your organization. Cable prep length will vary depending on the application and the fiber counts which are being installed. I will review the options available for cable installation in this video. The length table is provided in the installation instructions as a reference table. In this demonstration, we are using AFL's spider web ribbon. Any manufacturer's ribbon fiber can also be used as long as it is not bound with hard matrix holding all 12 fibers rigid and flat. For mid-sheath of loose tube and non-matrix ribbon, the fiber routing for the mid-sheath maximum length is as follows. The fiber will exit the sheath at the CAU mark. It will then enter the basket, do one slack loop up to the top of the crown, and then exit the basket on the other side. Next, cross the fiber behind the spline and address it in the tray on the opposite side. Secure fiber at the splice tray entrance. This is the location where the buffer tube will be terminated and bare fiber will continue. One complete service loop of the fiber in the splice tray and then one half loop more to the top of the tray. This is the maximum mid-sheath cable length designated on the length table, assuming that the exposed fiber is cut halfway with service length being the same as field length. Many times, the cut length can be shifted to gain more on the service side to splice. Be careful to leave enough fiber to splice if dead field side is ever used in the future. Mid-sheath minimum length is accomplished by removing the service loop in the splice tray. The cable end prep length for loose tube or non-matrix is listed in the length table with the same assumption, but allows the fiber to be brought to the furthest splice point. This will be discussed more in the splice tray video segment. Flat matrix ribbon is typically delivered in individual tubes or a central core tube. Either of these tubes can be run to the basket and secured there. This is the sheath to basket length on the length table. The cut lengths will still be based on outer jacket at the CAU retention. Flat matrix lengths are based on single height splice trays. If a deep tray is being used, the lengths will be the same as the loose tube lengths. Traditional single depth tray with hard matrix ribbon is waterfall spliced. This means all slack is stored in the basket or inner basket of Apex. This is the reason why the ribbon measurement is so much tighter. For any fiber type installation, the fiber or tubes will never go directly from sheath to tray without a slack loop in the basket. All fibers are routed in the Apex basket prior to entering the splice tray. The length table measurements in the Apex installation instructions are provided for reference only and provide a good starting point for cable installation. Your particular installation or application may require variations in the listed measurements. It is encouraged that your procedures define the lengths that work best for your needs, as there are many options. CAU installation with any double jacket cable, central core, or tubed ribbon can extend to be secured at the basket, leaving the outer jacket to bond grounds if possible and retain central strength members if applicable. When opening armored cable, leave a 1-inch tab beyond the sheath end to attach a bond shield to. This is applicable for all types of cable. It is recommended to leave both tabs and then cut one at a time of installation to see which tab is better positioned for the bond shield. When working with armored wrapping tube cable or a similar preferential bend cable, align the strength rods parallel to the basket. This may impact where your bond shield is installed. The ripcord slit in the armor should not extend into the sheath clamp retention. The armor layer sheath will end at the edge of the breakaway slot on the CAU with no slits beyond this point. The armor tab will extend for bonding. Each CAU is bagged and kitted independently at the bottom of the Apex box or from the warehouse if ordered separately. There are multiple CAUs for Apex sizes, but they all have the same features and functions. Each kit includes the following: the CAU itself with central strength member retention. There is a slot for sheath length as well as to break away if cables such as AFL's wrapping tube cable is being used and will not need to have central strength members retained. It is important to note the purpose of retaining the strength member is not for pull-out retention, rather it is to prevent the strength members from pistoning into the splice case with expansion and contraction of the cable through seasonal temperature changes. There is also a nest for the worm gear of the hose clamp to be retained. The serration is molded in for cable retention. These clips are where the small diameter spacer attaches if needed. Opening for alignment tab is molded on apex base. There is a 3/8 inch bolt for retention of CAU in the apex base. The unfilled hole in the CAU is not needed for any applications in the apex family. Hose clamp uses a 3/8 inch can wrench head. Universal spur bracket is not directional in installation orientation. Small diameter parts include a bushing, which will be used to measure if needed, tie wrap to secure bushing if needed, spacer to be used on CAU if bushing is needed. Determine if small diameter cable is being installed. This is typically under 0.55 inches. The easiest way to determine if this is needed is a bushing test. Take the bushing from the CAU and open it. Install over cable to be installed. If the seams of the bushing meet, then the bushing and spacer need to be installed. Snap the white spacer onto the CAU where this cable will be installed. This helps protect and seal small diameter cables. If the single cable diameter is less than the specified minimum diameter for a single cable, a multi-drop kit must be used. When using the multi-drop kit, the bushing and spacer will not be used. The blank inserts included with the multi-drop kit must be installed in all unused positions. On loose tube cable, it is very helpful to return the cable to its original lay after the strength rods and working fibers have been isolated. For all tubed ribbon fiber, the tubes should end close to the entrance of the basket as they cannot be stored fiber in tube in the basket. To mesh the tubed ribbon cable, simply cut tubes at the sheath to basket length. Cut the mesh at sheath to tray length. Make sure the tubes are free of gel near the sheath and secure the mesh at the sheath end with tape. If the colors of the tube are needed, decrease the mesh length by 6 inches and install mesh 6 inches from sheath. Secure mesh tube to basket. Wrapping tube cable or similar outer water blocking tape cable can also be prepared to allow the water block tape to extend the extra distance to the basket to protect it as well. For wrapping tube cable or a similar preferential bend cable, align all cable with the embedded strength rods parallel to the basket. This will prevent cable damage when coiling slack. Note, strength rod alignment with the basket does not mean the strength rods will be parallel with the CAU. For mid-sheath, you want to install the cables in the CAU to prevent a twist in the mid-sheath opening. This will be helpful for all types of fiber as it lets you open the fibers or tubes you need with minimal twisting from the sheath opening. Once the cable has been prepped, measure the strength member to the middle of the central strength member retention bolt for cutting relative to the end of the sheath in the fiber. This will be 2 to 2¼ inches typically. This is the same for securing both non-embedded side strength members in that structure cable. Make sure cable is free from tape, dirt, or contamination to ensure proper retention and sealing, and make sure no ripcord slits extend into the hose clamp retention. Open the hose clamp and install over the CAU in proper direction to allow the nose of the hose clamp worm gear to nest properly in the CAU. Slowly tighten and install the spur bracket at just short of 12 o'clock. The spur brackets will shift in final tightening. Make sure no tubes are pinched by the strength members and tighten the CSM retention bolt. Make sure the ground tab aligns where desired, typically on the side of the CAU for easy access. Once cable has been confirmed in the right location and that no fibers or tubes are pinched, tighten to 30 to 35 inch-pounds. This is about the most you can get on a handheld can wrench. Do not tighten to the point of damaging or attenuating the particular cable you are working with. Thin-walled micro cable and soft jacket indoor-outdoor are two examples of cable types where damage may occur when over-tightening. Thin-walled jettable microcore cable must be installed without the spur bracket installed. Is the small diameter spacer installed if needed? For loose tube, secure cable and strength members without pinching. For ribbon, central core or tubed ribbon, core or tubes may be brought to the basket entrance. This distance is the sheath to basket distance on the length table. Mesh may also be applied here to protect the ribbons. Existing tube and cable cannot route an apex basket. It must be removed. For wrapping tube cable or non-matrix ribbon, water block wrap can be used to protect the fiber to basket if desired. Make sure strength rods are parallel to the basket. Break CSM retention off CAU if not needed. For all double jacket cables, the inner jacket can extend to the basket if desired. Bring CAU to apex base and be careful to protect your fiber from snags or damage. Set the CAU into the base in a rotating motion to guide the hose clamp tail and align the tab on the base with the CAU opening. Firmly press and ensure the CAU is in place. The CAU should sit flat to the apex base before you begin to tighten the retention bolt on the CAU. Using a standard can wrench, tighten the CAU retention bolt. Dress fibers into basket. This applies for all mid-sheath, branch, and drop fiber cables. Peel tabs slightly from cable or tubes. Open the AFL bond shield kit and remove nuts. Insert the base tab centered under the tab and push down until the cable armor meets the bond shield stop tabs. Add the top clamp to stud and attach the first nut. Tighten to 30 to 35 inch-pounds or define torque by manufacturer if not AFL. For drop cables and very small diameter cables, a multi-drop kit is needed. There is also a two-way drop kit for apex. See individual closure and kits for diameters. Now that the CAU is installed, it is time to replace the sealing wedge. To replace, depress the inner gel block by hand. This helps ensure the sealing wedge tabs will engage properly over the gel block. Make sure the gel compression screw is completely in the relaxed or loosened position. Elongate tabs on the sealing wedge to ensure proper mating of the gel blocks. Engage the sealing wedge pins into the bottom of the base. Pivot the wedge into place. Depress the lock tabs and slide the latch down. Fully seat the sealing wedge on the apex base. Release the sealing wedge latch. Ensure it is fully seated. Attach the ground eyelet bond shield if applicable. Tighten to 30 to 35 inch-pounds or the defined torque according to the manufacturer if not AFL. If the cable is small enough that the bushing seams meet, the bushing must be installed on that cable. This bushing must be installed prior to compression of the gel compression screw. Open bushing and install over the small diameter cable with the taper towards the base. Take the supplied tie wrap and begin to secure it within the groove. Align the head of the tie wrap in the opening of the bushing slot. Pull the tie wrap to cinch and trim the excess. Do not over-tighten to deform the bushing. Slide the bushing towards the base port and firmly insert into the wedge gel. Repeat this process with outbound backbone from mid-sheath or opposing backbone or branch cables.